A smooth white lens parked over a mountain can look almost unreal, but it is a very real sign of invisible airwaves overhead. Lenticular clouds form when moist, stable air is forced up and over high terrain, such as a ridge, range, or isolated peak. That forced climb is called orographic lifting, and it is the starting point for the whole cloud. As the air rises, the pressure around it drops. The air expands, cools, and may eventually reach its dew point. When that happens, water vapor condenses into tiny droplets or ice crystals, and the cloud suddenly becomes visible. The important trick is that the air does not simply stop at the top of the mountain. It sinks down the lee side, then can rise and fall again in a repeating pattern downstream. That pattern is called a lee wave, or mountain wave, and it behaves a bit like ripples in a stream, only in the lower atmosphere. A lenticular cloud forms near the crest of one of those waves, where the air is rising and cooling enough for condensation. Then, as the same air moves past the crest and starts sinking, it warms again and the droplets evaporate. So the cloud is not a solid object sitting still. New cloud is constantly forming on one side, while older cloud is disappearing on the other. That is why lenticular clouds can appear fixed in place even when winds aloft are strong. Stability is the key to their neat, polished shape. In a stable atmosphere, air that is lifted tends to sink back towards its original level. That restoring motion helps create a standing wave instead of a messy tower of rising air. If the air were unstable, the same mountain lift might help build cumulus or even thunderstorms, but in stable, layered flow, the air can stay smooth or laminar, giving lenticular clouds their clean lens or flying saucer look. The best-known mid-level form is called altocumulus standing lenticularis. It is often smooth, rounded, and sometimes stacked in layers like plates. Those layers can form when separate moist bands sit at different heights, each reaching saturation at its own part of the wave, while drier layers remain clear. Three ingredients matter most: moisture, strong wind crossing the mountain, and stable air. If the air is too dry, no visible cloud forms. If the wind is too weak or blows the wrong way, the wave may not organize. If the air is too unstable, the cloud shape becomes rougher and more convective. In Australia, these clouds can appear over places such as the Australian Alps, when the airflow, moisture, and stability line up. For people on the ground, they are a beautiful clue to how the atmosphere is moving. For pilots, they are more serious. Lenticular clouds can point to mountain wave turbulence, rotor activity, and strong downdrafts on the lee side of a range. The cloud itself is not the danger, but the airflow that makes it can be powerful. To spot one, look for a smooth lens-shaped cloud that holds its position near or downwind of high terrain. If it keeps its shape while other clouds drift by, you may be looking at the visible crest of a mountain wave. Lenticular clouds are a simple reminder that the sky is not still. Air is rising, cooling, condensing, sinking, warming and evaporating all at once. The calm-looking disk above the mountain is really a marker of fast-moving air, shaped by terrain, moisture and stability.